so far? Good. So, we have some people that came in midday. All right, good. You came in for your first session at a really good one because we're going to be talking about AI agents. Has anyone heard anything about AI lately? No? Yeah, okay. Maybe just a bit. All right. First of all, I want to thank, our diamond sponsor, USAA and St. Mary's, for a great facility and really helping us out making this a great event. This has been a few years now. We've been holding this at St. Mary's. Also, very grateful to support of Spectre Ops. And as we go, if you haven't yet, the restrooms are out here and to the right and down the hall past the little couches. So should you need that, that's where you can go. Was that on purpose?
No.
Okay. So we will get those images back very soon. My name's Jeff Rich. I'm one of the volunteers here. This session is going to go until 2 p.m. Peyton has asked that you save your questions, so make note of them, and we'll have time for questions at the end. And I'll walk around with this so you can ask your question and be heard. And I'm going to stall another 30 seconds until the projectors come back online. Oh, the hoodie came off. Now we're getting serious. So I'm just going to ask this. Yeah, I'm stalling for time, but I am interested anyways. How many people, this is your first BSides? So what do you think so far? Thumbs up, thumb down? Oh, good. All right, yeah, you can't beat it for the value, the quality of the speakers, some of the swag you can get, networking. I mean, it's a really good it's local. I'm assuming many, if not most people are local. So it's a good opportunity for that.
I can scoot this over.
It looks like we have things going again, if not maybe a bit precarious, but we do have it. So I think we can get ready to get this underway. And you're going to hear about AI agents, augmenting, vulnerability analysis, and remediation from Peyton Smith. Please welcome Peyton.
Okay. Can you guys hear me okay? I'm sort of not close to the mic, but yes, in the back. All right, sounds good. All right, great. So we're going to be talking about AI agents today, and specifically augmenting vulnerability analysis and remediation. So just to start with a bit about myself. So I started my career as a software engineer and have spent about 10 years in cyber. Started in threat intel, so tracking threat actor activity by building malware analysis pipelines. Moved to CrowdStrike Services for 5 years. I split time between their cyber intrusion team and their red team. I've seen a lot of eCrime nation-state cyber intrusions, and have also hacked in a good chunk of the Fortune 1000. I left in 2024, to start a business. We're backed by Google, and we're trying to do exactly this. I promise this is not a vendor talk. We'll have like one slide at the end in terms of what we're focusing on, but I think just with how new large language models are, I think there's a lot of evangelizing to do, especially in this community, the community that we're all part of, because I think we naturally do not trust technology. So that's why I'm here. So in terms of why you should care, I truly believe that large language models will revolutionize most industries, and I think security is no exception. I do believe that, and this is, I think, also what we'll be talking a little bit about today, is that there's a lot of trust problems in cyber, and so I think cybersecurity will probably be one of the last verticals to fully integrate language models, mostly due to the low risk tolerance, right? Especially on the SOC and IR side. If you make a mistake and classify a true positive as a false positive, that could lead to a massive problem. And so what that means, though, is that human-in-the-loop workflows will dominate for a long time, where we're sort of using these language models to augment our workflows. And I think all of our jobs are safe for the foreseeable future. All right, so just to kind of start with a few goals for this talk. So just some basic ideas is that we'll be able to, or everyone in this room will hopefully be able to understand AI agent terminology and basic agentic workflow patterns. You'll understand sort of the base building blocks that a lot of AI agents are built upon, and then you'll also understand how to mitigate some of the inherent risks with language models. Okay, I understand there's a lot of different skill sets in the room today, so I want to spend like 3 or 4 slides on basics, and then I promise it'll get a little bit more interesting. So in terms of what is a large language model oversimplified, so if there's some actual AI folks in here, please don't throw things at me, but really it's just an advanced autocomplete system, right? So it's predicting the next word or token or number in a sequence based on its huge training set. And its training set is massive. It's pretty much the entire human knowledge database. New York Times, I just put that there because the New York Times sued OpenAI for using their data, but it could be YouTube data, but it's not necessarily security data. There's probably some security and product documentation that's built in, but in terms of, if it's trained on gigabytes or terabytes of logs, not really. And so each time one of these models is trained, it costs a ton of money. Right, so GPT-4 cost about $100 million to train, and then GPT-4.5, which was released earlier this year, cost about $500 million. And so because of the cost to train these systems, it's done very, very rare, right? It'll be done once every 6 months. And so it's sort of a theme throughout this talk is that we need to find a way so that the models will always have up-to-date information, because what it's trained on is not accurate, right? Especially in cybersecurity, when you're dealing with an active new threat. All right, maybe it's a new threat actor that's doing something brand new. They're exploiting some CVE or whatever it might be. The language model is not going to have that information. So how do we go out and get that information and provide it to the language model? Okay, just sort of a funny note here is that, I think you'll hear different opinions in terms of are LLMs the future of life and, generative AI and artificial AI. And I think this can be sort of broken down into the leaders in the space, aka OpenAI, Anthropic, and Google say yes, right? But it was funny, I don't know if you guys saw earlier this week that Apple put out a paper which basically just said LLMs are overrated. That actually was released this week, and basically just said that, they're basically advanced autocomplete systems. They can't reason, and therefore, they're very, they're not great, right? And so, where is this actually? It's probably somewhere in the middle, but I think it's still to be determined. So in terms of open source versus proprietary models, open source, I'm sure everybody is familiar with what that means, but there's some models there on the left-hand side that are all open source, and there's sort of some benefits of that, which we'll talk through. And then there's the proprietary models, which I'm sure most of you all maybe use today for your personal needs. And so there's different benefits and drawbacks to different types of models. So open source is obviously going to be cheaper. It's typically going to lag behind a little bit in terms of performance. If you use an OpenAI versus maybe a Llama or something else, generally the open source models are going to be lagging a little bit behind, which, by the way, isn't necessarily a problem. It just depends on your workload, which we'll talk about later. In terms of customization, open source, as we all know, is high versus proprietary. You're going to have to go through some roadblocks. Scalability, if you're going to pay a lot of money for a OpenAI, I'm hoping that you can scale your large language model calls. And then privacy and control. This has actually changed a little bit here, because most of the proprietary vendors now allow you to host a version of their model in your private cloud. So if you work for an enterprise, you can host it in Azure, you can host it in AWS. So this is sort of shifting a little bit, but I think still open source LLMs, if you really care about privacy, are probably going to be your best bet. So just in terms of the release rate, so OpenAI releases a ton of different models. This is sort of their release cadence over the last year-ish. So they release a new model about every 3 months. It's interesting, though, because not every single one of these models is actually a brand new trained model. Sometimes they're just iterations. And so we'll talk a little bit about that as well. Last 1 or 2 slides on sort of basics. So all these language models are benchmarked today. So they all score differently at different tasks. This is a screenshot taken from March 21st, and you'll see that Gemini 2.5 had actually just came out, and so it was performing the best, right? So it's pretty much at the top of most of these benchmarks in terms of scoring. But I just took a screenshot from June 19th, and now you'll see that OpenAI's O3 model is now at the best, and then it's Claude, and then it's Gemini, right? And the point is that these things change so fast right now, and there's different models that are performing better at coding, reasoning, and so it's important. Well, A is that if I were to take the screenshot a month from now, I can almost guarantee that this is going to be different. All right, and so it's important, especially as we're building with these models. I'm going to make an argument that you should really build with the ability to plug and play with different models. It's sort of a key takeaway, meaning that we don't know which model is going to win in the long term. All right, I think over time this is sort of like a broader market opinion, but I don't know if it's going to be a Google wins all, right? It's sort of like a monopoly market. I think likely what will happen is some of these language models will start to specialize over time. If we go back to this photo, so Mistral as an example, they came out a few months ago and decided to specialize in Arabic, right? So there's sort of all these niche areas where these model providers can go. I think OpenAI is debatably going more consumer focused, and Claude is saying that they're going to focus on developers, right? So there's sort of all these different things, and we're way too early. And so going back to this point, that's sort of bottom point, is that we need to build with the ability to easily plug and play. And we'll talk a little bit more about this later. In terms of open source and proprietary, it really depends on your type of workflow. You don't always need that, like, Ferrari, right? You can sort of get by with pick your old car, depending on the type of workflow. And so we'll sort of talk through potentially a few examples there as well. Okay, that was actually a little more basics than I thought, but kind of moving on, I think, to how we can apply these models to cybersecurity workflows. Okay, and specifically when I built this presentation, I think CV analysis is probably something that everybody in this room has done or has heard of. And so we're going to sort of use this as one example. I think there's a lot of really interesting use cases where we can use language models. I think there's a lot of companies going after the SOC space right now, so like augmenting alert triage, things like that. But we're going to focus a little bit on a different area here. Okay, so CV, this is just the example that we're going to walk through today. So there's CV 2024-4577. This was a mass exploited PHP problem disclosed in July 2024. I'll reiterate July 2024 because we're going to come back to that later. And so usually if you're an analyst, you have a few questions when you're looking at a CV, right? A, what is this thing, right? A CV is just like a moniker that doesn't really mean anything if I just read it. Is there threat, act, or activity affiliated with the CV? So is there someone in the wild that is actively exploiting this thing? Is there public proof of concept code? If yes, I would like to see it. Maybe I want to test if my system is actually vulnerable. And then I think most importantly, debatably, is how do I fix this thing, right? So how can I tell my engineering team or IT team to actually fix this problem? And so I think the question we're going to ask is usually a human has to do a bunch of reading. Maybe they're going to read various data sources, threat intel, and answer all these questions. And we're going to try to have a language model automate all this for us. Okay, so just as an example, and this is a little bit dated now, but I sort of wanted to pull the audience here for a second. So we're going to use an older model. It's from GPT-01. As a reminder, this vulnerability was disclosed in July. And then this model was released in 2024. And so we're going to use GPT-01 to analyze this problem. And when I say that, we're just going to go into chat GPT, we're just going to ask it about it, right? And so I wanted to ask everybody, and maybe just like a show of hands, who thinks that the language model is going to be able to answer all these questions about this CV? Got one, okay. And then partially. All right, and then it will fail. All right, nice. Okay, so this photo was taken in March 2025. And so again, we're using this O1 model that was released in December, so 6 months before the CV was released. And it says, I'm not aware of this vulnerability at all. Right? So I think this sort of shows that pretty much just means that this model was trained before the CV was released, even though this model was released 6 months after the CV was actually disclosed, right? And so I think this sort of gets to a point that I was trying to make earlier, where we really need to have or provide these language models the ability to go out and get relevant context that is relevant today and not from when it was trained. And so, cybersecurity isn't the only industry to have this problem. And so there's been this idea called RAG, which is retrieval augmented generation. It's just a fancy moniker that essentially is going to have the language model go out and retrieve information to answer your question, right? There's one sort of important caveat here is that LLMs have a context window. This is basically just the amount of information that it can analyze at one time. That's a vast oversimplification, but please just bear with me. And so we'll sort of run into problems because we can't get a ton of information and throw it at the LLM because it just won't be able to analyze it all. So we need to sort of be careful with the type of information that we are sending it. Okay, and just so a diagram of a RAG app, just so y'all can sort of see this. So modern proprietary models, they all have this implemented today. It's not just a core large language model. But so what happens is that you're going to ask the model a question. It could be the Chat GPT app. The app is going to go out to the internet. Typically, Google is just probably the standard information knowledge source today. It's going to Google for relevant information, and it's going to throw it in that context window, and the LM is going to analyze. In addition to its training set, it's going to look at that context window and try to answer your question, right? So again, it's sort of augmenting the trained LLM with additional information after it was trained. Okay, hopefully it's going to work. Let's see. Is this good? All right, so this is a newer LLM, and I'm going to hopefully pause it here. So I'm just asking it to describe. I don't know if you guys can see this. It says right here, it says searching the web right there. So this is now the standard. If you go to any proprietary model, this is what they're doing. And it's because they have this huge problem where the LLM would just hallucinate nonsense if you asked it anything new. And so they basically built these RAG apps that recognize when the LLM doesn't have the right data, and they try to go out and find the data, right? There's a few, and I'll sort of let this run here for a second. So it was actually kind of interesting too. I know it's really small, but you'll see that they'll actually provide little icons there. I'm trying to pause it, but it's not working. So it says GitHub, NVD, and other sources, and they'll actually cite the sources for you. So I know it's really small, and I'm going to see. Let's see. I think So what they'll do is you can sort of hover over articles on the right that it used to actually augment its training set, so it has the right information. Okay, I'm going to move on here. Okay, so sort of second takeaway here is that in my opinion, especially for cybersecurity workflows, this RAG portion of the app where you're going out and getting relevant context is incredibly important. Without it, your language model is just going to be sending you nonsense and wasting your time. And so I think we can go a lot further here, and we'll talk a little bit about this later. But searching Google is just public data. Especially if y'all work at an enterprise or a organization, we really want to search your internal data, right? Searching Google is nice, but it's what about your proprietary threat intel? What about your CMDB? And another internal knowledge repository, SharePoint, to sort of allow you to augment a lot of your analysis. Okay. This is sort of just reiterating what I was just talking about in terms of Google RAG, right? So you're going out to Google. That's not a technical term, by the way, so please don't use that. But in terms of just to kind of show what Google RAG was able to do in terms of the initial response where the language model says, hey, I have no idea. It's able to provide a coherent answer about what is the CVE, a good description, or a good description including versions that are actually affected. It can provide threat actor activity. It is pulling from public threat intel, which isn't great for a lot of reasons, but it's at least a step in the right direction. Is there public proof of concept code? It does say yes, but it doesn't generate it for us, so that's not ideal, and we'll kind of touch on that later. And then it is able to provide some decent instructions in terms of how to fix this problem. But again, it's very generic. It's not tailored to your enterprise. It's not tailored to the affected system that you're actually trying to remediate. And so we'll touch on some strategies there later as well. Okay, so some drawbacks of that just example that I just showed. I don't want to have to go into ChatGPT every time and manually type whatever I'm looking for in, right? We want to hopefully automate this. As we talked about, OpenAI uses public data. That's okay, but it's not great. And then, I pretty much said the rest of these. So the idea that we're going to try to solve for here is how do we improve upon this, right? And try to automate this into our workflows today. So you don't have to have your 4 tabs open where you're, querying your ServiceNow and you're copying and pasting things into ChatGPT. I pretty much already talked about this. So now we're going to move on to trying to automate this. And further, we're also going to try to integrate internal data. This is more of an enterprise topic, but at least part 2 is. Part 1, I think we can all build scripts in terms of automating your own workflows here. Okay, and so to do that, to actually automate this, we're going to talk about agentic systems. So every large language model provider, well, every proprietary one, has their own API, right? So this could be a traditional library. You know, if you guys have all written in Python, you're importing something, and all of a sudden you have all these pre-built function calls where you can write or communicate with the language model. And so to kind of go back to takeaway one, though, the problem is that every language model provider's API is drastically different. Right? And so if you were to try to build a script or a framework where you want to be able to easily plug and play with different language model providers, you would have to pretty much rewrite the small script 3 times. And so we don't have to do that. You know, if we're down the road and we're building on Gemini, and Gemini all of a sudden doesn't support our use case, that would be terrible. And so again, people have started to solve this problem by building what is called agentic frameworks. And so they provide sort of they provide an abstraction on top of language models so that you can easily plug and play with different models. They're also pre-built with a few popular agentic patterns, which again, we'll talk about later. And they can also sort of allow your LLMs or agents to work with various tools. So the most popular ones, I think maybe 6 months ago, were LangChain and LangGraph. There's a few other ones as well. Crew AI is a startup. Agno, I think, is also a startup. AG is Autogen. It's built by Microsoft. There's all drawbacks and positives to these frameworks. We'll sort of use LangChain and LangGraph mostly as just examples today, so you can see how they work. But I'll say that the downside is that even these, just because of how new this sector is, even these can be unstable. When we started building at Specular, we were using LangChain heavily, and LangChain has had some problems. I still think it's a great framework, but it's we've had to rewrite some of that as well. So choose at your own peril. Okay, so to kind of show an example of using LangChain here. So essentially what I'm showing here is that this is the same script that we were just looking at, but what they allow you to do is just initialize a language model in one line, right? So in this same script, you can sort of, it's just one line of code difference to either use ChatGPT or Claude. Right, so you can pretty much build an entire script and then just have one line that actually chooses what language model you're actually using for that workload. So again, it allows us to easily change. If Claude starts performing terribly for our use case, we can always swap and use something else. Okay. Sort of introducing one more terminology here. Anthropic actually released a blog in 2024, which is sort of released or talked about some terms which are now standards here. So there's workflows, which are predetermined sort of code paths that a large language model can take. And I know this is a little bit vague, and we'll sort of walk through an example here. And then there's agents. Agents are where you're providing a large language model the ability to sort of choose its own direction. So this is a little bit of a new concept, because I think if anybody's written code before, your code is going to execute directly down the lines that you told it to. That's similar to a workflow. But agents, you're providing the language model to choose the route or the road that it's taking to complete a task. So all of a sudden you're sort of like releasing the control, and that's where it kind of gets weird sci-fi things can happen. But I think it also provides additional capabilities that maybe weren't present in legacy traditional code, right? And so we'll talk through some examples here. Okay, so we're going to start with the simpler one, which is, again, a workflow. So it's using a large language model in a predefined code path. And so we're going to try to use it to answer 2 of our CVE questions, right? So what is the CVE? Really, it's a text summarization problem where we're going to read in a bunch of text and try to summarize it. And that's a perfect use case for a language model, and specifically a workflow, right? It's not very complicated. You're just going to read text and then summarize it. And then is there threat actor activity affiliated with a CVE? Also, mostly just text summary. Okay, so what a human would do, what I would do is I would probably look this up in the National Vulnerability Database, and I would read through all of these sources, right? And probably some relevant threat intel. The problem with this is that what we talked about before is that all this information will not fit in the LLM's context window. That's that finite amount of space that a large language model can actually analyze. And so we need to sort of build these workflows that are going to help the language model summarize this information. There's actually several options here. All right, this is a very complicated graph. If y'all remember earlier, I mentioned that some of these agentic frameworks like LangChain come pre-built with some popular workflows. So this is a fancy text summarization workflow that uses MapReduce. I learned about MapReduce in college. I don't want to learn about MapReduce again, but I'm glad that it's already implemented here. And so we can sort of use this pre-built workflow, pipe in all this text or text from all these links on the right-hand side, and then have the language model summarize an answer for us, right? So that's sort of one example of a workflow. A second is that, so there's different types of workflows. So this is called the refined workflow, where essentially for each of all those links, you're going to have the language model analyze one, and then prompt it to update its answer based on a second piece of information, right? So we're going to iterate through all those 14 links, and we're going to have the language model sort of update its summary or its answer every time. So it's a different strategy than MapReduce, which sort of tries to distill information into one summary. It's sort of, this is more of an iterative process. And so there's different types of workflows for different use cases. You sort of have to mess around with what actually makes sense for your use case. So as an example, this use case might be better for aggregate all threat actor activity, because it's basically going to look at its answer, look at a new article, see if there's new information about, new activity that isn't in its current answer, and just like append it. Right, so it's just a slightly different type of workflow. All right, building agents. So now from workflows, we're going to get into agents, which are a little bit more complex and non-deterministic code paths. Sorry, I'll come back here. So this is an example from LangGraph. So LangGraph is, maybe as their marketing suggests, LangChain is a predetermined chain of actions, right? LangGraph is all of a sudden you have this graph where sort of the agent can choose which direction it takes in the graph to get to an answer. And so they're sort of stateful graphs. Just kind of briefly walk through this example. I think the biggest note here is that if you go to the right-hand side, let's just say that you have an agent execute a task, right? If it fails, you can have it in the graph to go back to earlier in the graph state to edit its strategy, right? So this is a very common agentic pattern where the agent sort of just iteratively tries to find the answer, right? And you have a note at the end that says, hey, did you succeed? If not, go back, right? And it sort of replans and tries to actually get to the answer. And so there's a slightly better example of this later as well, which I'll show. Okay, so generally agentic patterns are better for more complex tasks. So anytime you're writing code, does anybody use cursor in here? Cursor? Yeah. Most modern IDEs today, if they have a language model embedded, are using complex agent or complex agentic patterns here. And then in terms of also how do I fix this problem, this can be a little bit complex too, especially if you're actually trying to generate a remediation playbook, a PowerShell script, whatever you're going to actually fix the problem with. These can be a little bit complex. It's no longer just a summarization problem, and so you often need an agent to kind of help you out here. Okay, so this is sort of a example of a kind of a simpler agentic pattern for cybersecurity. So let's say, to kind of continue with our CVE example, let's say that we wanted it to help us with remediation, right? So A is that you sort of have your task and you're say, hey, help me remediate CVE 2024-4577. You have an orchestrator agent, which basically gets to determine what it needs to do, right? So it can either go out and query the CMDB to look for asset owner, changes made to this asset in the past, inventory on the system, Or it can also query product documentation, right? So maybe you have indexed all of your PHP documentation and you want the agent to go out and find interesting information. And then you'll want to combine that information into a synthesizer, which is basically going to be a summarization, but it's sort of intelligent, and then you're going to generate a sort of like a how to fix it playbook. Okay, so give me 1 sec. Okay, so going back to the slide, these integrations today to your CMDB or to your product documentation, which is traditionally stored in a vector DB, these integrations are actually pretty tough to build today. If you were to ask an LLM to make an API call to ServiceNow or to pick your favorite product, the language models are generally terrible at it. And so again, the community here has recognized that something needs to be done here, and so they've built something called the Model Context Protocol. This was released also by Anthropic, and then was adopted by Gemini and OpenAI. So it's now sort of like the new standard, and I think you'll basically start to see the MCP protocol or the Model Context Protocol a lot more often here. And I think I just said all this stuff. But really what it allows you to do is it allows a language model to start communicating, and specifically in these agentic patterns, which are a little bit more complex, with these third parties, data sources, to get information it needs to make a answer, right? So this is a bit of a architectural diagram here. Really what's happening, and again, I actually think this is what OpenAI and a lot of these proprietary vendors are actually doing under the hood, is that they've basically implemented a version of this protocol where they'll be able to go out and get information from Google or other data sources to actually answer your question. This is a little bit of a architectural diagram. I think this one's a little bit more abstract, and I think it might make more sense, hopefully, to everybody. So if you have your laptop here, and you have USB ports, right? If you plug in a USB or to connect to your TV, it's sort of like an adapter to project your system onto your TV. So it's a very similar workflow where you're sort of plugging in these modules, and all of a sudden the language model can communicate not just with ServiceNow, your SIM, Splunk, but your Google Calendar, right? It could automatically read your Gmail and just start creating Google Calendar invites, right? Or it can start sending Slack messages for you. So there's all these plugins that people are building, and I want to emphasize people because really what's happening now is there's these sort of public GitHub repositories that aggregate a lot of MCP servers that people are writing, or these plugins, and they're not really officially supported yet. So this is still very, very new. And we're probably going to see where this goes in the next 6 to 12 months. But in my opinion, this is probably going to be the future, where you're going to have all these companies maybe even sponsor their own MCP plugins, and you'll see the community start to use them. Just briefly, some benefits here from MCP versus traditional LLM calls is that MCP has memory. So actually, if you've noticed, if you've chatted with ChatGPT long enough, it starts to memorize things that you told it before, right? And so very, very similar here, where maybe the MCP server is going to know that you like your calendar invites in a specific manner, right? And I'm going to skip some of this for time because I know we're running out. And so the idea here is that, again, during our agentic patterns, we're going to have a MCP server that's going to go out and query information from ServiceNow about the asset. It's going to pull it in so that it can build a customized remediation plan for you. And maybe it's going to also query Microsoft's documentation to look at how to update a web server, right? So all of a sudden, you're sort of having this dynamic agent that can go out and query information from all these different plugins to help you with your job. Okay, so that was it. Sort of closing here, I probably got a few more minutes. I think everybody's, or a pain point for a lot of people in cyber is, how do we trust the output of language models? As soon as it starts hallucinating, I think it almost adds more work because you have to go back and check the answer of the model, right? And so it's a huge problem. So there's a few strategies here, and by the way, if you've seen a lot of the proprietary vendors over the last 6 months, they've gotten a lot better here. Predominantly through RAG, which is what we showed earlier. That's just sort of the default workflow, where if they basically have a system that says, hey, am I confident about this answer? If not, go and look for extra info here. It's also large language model grounding, which is a technique released by Google that tries to, it enforces a language model to have extra current information to actually provide you a answer. So there's sort of different strategies here that are approaching, and I think over time we'll continually get better here. You can also double check the LLM's answer. So if y'all have seen Chain of Thought, you can sort of prompt the language model to provide you a detailed analysis in terms of how it actually got its answer. And you can kind of read through that. And also, if you ask the LM to cite its sources, it's shown to actually just improve the answer just by itself. Sort of skipping through here for time. I'm going to skip this. Sort of one important type of workflow here that I also wanted to show, and we were talking about this earlier, is you can have these agentic patterns here where you have a language model output some type of data, and then you have a second language model that checks the result as a separate entity and basically says, hey, does this result look good? And if not, send it back. Right, so this is basically called you're sort of having a LM evaluate the results of a previous model. And so you can build these with these frameworks that we talked about earlier. And so this is a very common IDE coding path where basically there's a ton of checks. And this is all typically in a graph, but I'm just showing you here just for a more concise sort of view here, where the LLM is consistently has a secondary resource where the secondary resource is checking the LLM's answer, and if it's not right, it's just sending it back. And so traditionally, this loop can go forever, right? But at some point, you sort of just need the LLM to fail or possibly make up data, right? But over time, I think you'll see these types of workflows where you have an independent language model evaluator become very, very common. Okay, last two slides, I think, and I'll sort of skip most of this. I'll skip that one. Skip that one. So this is more in terms of what we're building. Just one quick slide on this is essentially we're taking that sort of deep research or the ability to cite internal data sources and sort of apply it to your specific workflow or whatever you're actually reviewing, right? So whether it's a CVE, whether it's a alert, we're sort of building that RAG data pipelines to go out and grab information that are relevant to your workflow. And so the idea here is that not only we'd integrate with ServiceNow, but also be Azure, AWS, CrowdStrike, Jira. Pick your tool, because we don't want you to have 4 different tabs open, right? We sort of just want a singular view of that, and the language model is sort of assisting you in how you're looking at data. Okay, last slide. So takeaways, highly leveraged RAG workflows. I'll say also that the space is changing incredibly fast. I pretty much have to update this deck every few weeks. I really believe that AI agents and language models will help augment a lot of your workflows. You kind of just have to dive in. And I hope this inspired you all to start building. And that's it. Thank you very much.
We're going to let Peyton catch his breath and have a swig of water. We have some time for questions. So if you have a question, raise your hand. I will come to you with the mic, and you can ask your question. If you would, just mention your first name when you ask the question, please.
Okay. So I'm Sean, and my question is, when it comes to this research for pulling in information, how well does it do the checks and making sure that the information is actually accurate? Because I mean, anyone can publish on Medium, anyone can publish on GitHub, but how does it determine where, I guess, trust, like a truthiness rating if you want to go by Colbert?
Yeah, sure. It doesn't. I think what you'll start to see and what we've started to build is basically you almost have these data pipelines where you look at the reputation of the source and you have to analyze the integrity of the data before you feed it to the context, because the language model has no idea. It has no internal reasoning capability, so you sort of have to do that for it, which, by the way, is why I think Scale AI and all these popular, which was just bought by Meta for $14 billion, they got acquired because that's their entire business model, is they're tagging data so that it's reliable for these models. So yeah, it's still a challenge today.
Another question here, coming over. I'm coming this way.
My name is Brian. You ran out of time, but I just was curious whether you're going to say anything about A2A, Google's agent-to-agent new thing for MCP.
I actually have not seen that yet.
Okay.
I'll have to look at it. Yeah.
All right.
Thanks.
Okay, another question up front, then I'm coming back to you.
Karina, and my question is, what current LLM projects are you working on?
So I'm the founder of a company that this is sort of all we do. We're trying to do actually a lot of what we just talked through today. So using language models to augment CV analysis and helping security analysts fix security problems. Yeah.
Hello, I'm Robert, and I was wondering, with all this research that you've done going forward, what do you think this will do to the career field for people in cyber? Because so I'm a student learning about cybersecurity. A lot of what my professors have told me is that, one, not to use AI, but two, that it's not going to be important because you still have to know what you're talking about, regardless of AI. But now that you brought up all this information, it seems a little unclear.
Good question. Let's see. Not to use AI. I don't agree with that. I think there's a quote that I'm going to butcher, but it's basically like, you will be replaced by people using AI. You will not be replaced. So I think it's similar to a huge technology shift where everybody started using email, right? It's just the same thing. It makes you more effective. I do think it's important to understand how the LLM is getting its answers, and you still need to understand the basics of cybersecurity, right? Like you maybe one thing that we talked about today is that you can't treat it like gospel, right? You have to still understand, and especially for the foreseeable future, it can augment your work, right? But you still need to be able to tell also when it's probably hallucinating. So there's a balance there. So maybe agree that you still need to actually understand cybersecurity. Disagree that you should definitely be using it as much as you can.
Time for one more quick question if someone has one. Is there one up front? Oh, there is one up front, okay. Thank you for helping me get in my steps. First name and a question.
Hi, my name is Ramon. So I started looking into, I don't know how to say the name, but it's like N8N. And so what they do is, or NAN, I think, it is AI agents. And so they do what you were saying. And so how important is it to understand how to create these agents to better your workflow?
Yeah. AI engineers are definitely the most sought after career choice right now. There's, I think it just was public that Meta offered some OpenAI engineers like $1 million signing bonuses and some other nonsense. I think if it suits your personality to code and to build these agents, I think it's a great career choice. Definitely won't be getting replaced. Or you could use tools that use them. I think there's lots of great career options. you just got to pick what interests you.
All right, well, thank you very much, Peyton. Please join me in giving Peyton a hand, and thank you very much for the presentation. And please accept your small token of thank you for the presentation.
Thank you very much. Thanks for your time. I got a little.
We have our next session starts in about 6 minutes in this room.